The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to today's webinar where we're going to be taking a look at native MySQL replication and comparing it to the features of Tungsten Replicator and Tungsten clustering. My name is Chris Parker. I'm the Director of Professional Services for the EMEA and APAC regions. I'm also joined today by my colleague Matthew Lang, the Director of Professional Services covering the Americas, and we're going to be doing this presentation together. Before we get started, there's just a little bit of housekeeping to go through. The webinar today is being recorded, and following the session we'll be posting it online so that you can go back and watch it again at your leisure. A copy of the slides used are also available right now from the GoToWebinar control panel, so feel free to download them. If you wish to ask questions, please do so. Type them into the control panel as a questions and answers box. We'll try and answer the questions as we go, but if we don't get a chance to answer them for you during the session, we will post out all the answers to you at the end. So with that out of the way, let's get started. And when my slide moves on. There we go. So today's webinar, as I mentioned, we're going to take a look at the following topics. First of all, we're going to start looking at native MySQL replication and just understand some of the features and limitations. And then we'll look at Tungsten Replicator and see how that compares. And we'll talk through some of the complex topologies that you can configure and an overview of the powerful filtering features as part of the replicator. We'll finally just briefly look at tungsten clustering and see how you can leverage the power of the replicator combined with the clustering software to build out a fault-tolerant cluster providing HA and DR and a number of other benefits. And hopefully I'll give you an idea of where our software sits alongside what the native MySQL replication can offer and help you make a decision on which path you wish to take in your environment. So let's start looking at MySQL's native replication. So MySQL have provided replication now obviously for a very long time, and it's fair to say it's very simple to set up, it's very easy to use, and combine that with the fact that it's free and built into the software, then you have right out of the box a very simple solution for replicating your data. It's embedded within the MySQL engine, which means that it can be very fast. However, it is only a single-threaded process, so that can introduce lag and overhead if you're dealing with very, very busy systems. In around, I think it was about 5.6 of MySQL, they introduced parallel replication, but that's only limited in that you can only still have one single thread per schema. So it's really only useful if you have multiple schemas in your source. Now it's very simple to add more slaves to replication. MySQL dump, export, import, set the master and start positions, and away you go. And you can also chain slaves. However, you can only set up what we call a one-to-many topology. So one master, many slaves. One slave cannot have multiple masters. Couple that with, if you want master, then you need to be extremely careful. By default, any user can still, if they have super privileges, you can still write into a slave, and you can cause all kinds of problems, and then you have lots of conflict issues to face when you're in a master situation. It can start becoming very complex and very difficult to manage and look after. Because of the nature of replication as well, it's possible that your application could read stale data from the slave unless you start building intelligence into your application to check replication state. I mean, that's a limitation of most replication products if you're in asynchronous mode. Now, with MySQL, you can be asynchronous. You can configure it to be synchronous or semi-synchronous. It provides lots of flexibility and helps you to control the flow of data, and in some way that can eliminate the chance of reading the stale data. But synchronous replication in itself can provide additional complications and limitations. Anytime you need to change any parameters to handle replication, you're going to need to stop and start your database. That's not always great. Most people, it's a production system, and you want to be able to manage this with zero downtime. So it's very difficult to do zero downtime maintenance because it's very difficult to fail over, for example. Native replication is often seen as a simple and easy cluster solution. I get that. I too have been a DBA and relied heavily on native replication to provide HA and DR in a very busy production system for an e-commerce solution that I used to work for. It worked well, but when it broke, we would often face a lot of downtime whilst we had to perform role switches. And even then, after a role switch, you would often find yourself having to manually patch up the old slaves and repoint them to the new master, and then any changes higher in the stack to allow applications to connect to the new master. So all of a sudden, what should be a simple failover or switchover process could often result in hours of the application running with limited capability because you have slaves out while you rebuild them, and hours of manual DBA work to fix. All of these complications can be resolved, and MySQL are slowly adding further improvements and tools to make failures much easier to handle. However, it still requires many different additional components to be acquired and installed, or topologies changed. Some of the examples that you can do with MySQL now is you can bolt on MySQL proxy to handle the application client side things and failovers. They've got group replication in a newer component in the later releases of MySQL. But these are all many different components that don't necessarily integrate very well with each other, and they all add further complexity. They're also relatively new and in their infancy. With native replication as well, you do have the ability to have some basic filtering functionality, such as including or excluding tables and schemas. So it can be useful for providing limited replication set to reporting nodes, but that's about it. You can't do any complex filtering. And obviously it's MySQL native, so you can only really replicate MySQL to MySQL. So let's have a look and see how that compares to Tungsten Replicator. Well, firstly, we do have an open source version of our replicator. That's free. We also have a commercial version. With that comes full 24/7 support and product updates through the life of your subscription. Now, a lot of what we're talking about today applies to both the open source and the commercial version of our software. Now, the open source release contains many benefits, but obviously there's some of the newer features, newer the replication targets that are only available in the commercial release. With Tungsten Replicator, we replicate transactions asynchronously. We sit outside of the database engine, unlike native replication that's built in. We sit outside of it. So you don't need to make any application changes or structural schema changes for us to be able to replicate your data. It also means that because of the way we extract information from the binary logs, that data loss and inconsistencies are less likely to happen between master and slave. As soon as a transaction is committed into the binary logs, we can replicate it, even if the source database has crashed in the meantime. So you know that anything that was committed prior to that crash, we'll be able to get it out, we'll be able to replicate it. Native replication, if your application crashes, you've lost your replication stream, so you're not going to be able to get that data. So you may end up with transactions that got committed into your master that have not necessarily made it to your slave. And that obviously is more overhead for you to then try and patch that up, especially if your master was lost through quite a disaster. We can configure many different topologies, such as one-to-many and many-to-one, and we're going to look at those over the next few slides, so I'm not going to dig too much into that right now. We also have the ability to apply in parallel on a schema level basis, similar to native replication. And one of the more powerful features of our replicator allows us to apply very complex filtering at different stages of the process. Matthew's going to be talking about the filtering shortly, so I'm not going to steal his slides. I'll let him talk about that when we get to that point. Our replicator can also replicate between heterogeneous source and target combinations. The one single product can do all of this with just a slightly different configuration applied during install. As you can see from the list, we're able to extract out of MySQL, including Amazon RDS and Google Cloud SQL, or Oracle, and we can apply into a whole range of different targets. So I've got listed there, we have Oracle, Redshift, Vertica, Hadoop, Mongo, Elasticsearch, Kafka. Couple that with the various complex topologies and our complex filtering, and the replicator suddenly becomes much more than just a simple data movement tool. It can open up your data to a whole variety of target use cases. And we're also continually developing the product and adding more and more targets. And soon we'll also be expanding on some of the sources that we extract from as well. So do keep an eye out of our newsletters and on our website for upcoming webinars where more and more information of this sort of thing is revealed. I'm not going to go into great detail here about the ability to switch roles. I'm talking about the replicator only right now, but it is we'll cover that a little bit more when we get to clustering, but I just want to highlight that the nature of the way that we're installed and configured means that switching a replicator role is very simple. It doesn't require massive reconfiguration of the database nodes. We don't need to start logging in and moving things around. We can just flick, very simply, we can just flick the role of the replicator from master to slave. The way we do this, we use global unique identifiers. Let's have a look at that now on the next few slides. We'll look at the way the replication flows. So as I mentioned, we sit outside the MySQL engine, and by default we would install the replicator on the host. It is possible that we can install on a different offboard host if required, providing we've got access to the binary logs and a log into the database. We're going to work fine. Now, based on the configuration during install, the replicator will know whether it's to be running as an extractor, which we call the master, or an applier, the slave. Again, it's the same single install package, just a different configuration. Now, in extract mode, the replicator will be mining the binary logs from the database, or in the case of RDS, we actually hook into the native replication protocols and pull out the data. And from that, we take the transactions, we assign this globally unique ID that I mentioned, and we convert the transaction into what we call THL, or a transaction history log. This is our own native format, and it's this reason that allows us to replicate between heterogeneous targets. The THL contains a fair amount of metadata and the events and data changes themselves. This is then sent across to the applier replicator, where the THL is then converted back into native language appropriate for the target and applied. In the case of Oracle and MySQL targets, we apply that via JDBC. So then the use of the global unique ID, or the GUID, that helps us to track and maintain the consistency. As we replicate, we also maintain a state and position in a small tracking schema in the source and target. So we know exactly where we are and what position we're at. So if there was a break in replication for any reason, as soon as the link is reestablished, we'll pick up where we left off by looking at the tracking schema, finding out what the bin log position and the transaction ID are up to, and off we go. This decoupling from the database and it being a separate process means that even if the link is down on the extractor, we can still be working and generating the THL. And then as soon as the link is reestablished, we can just pick up and carry on. The GUID is associated with the specific binary log event and transaction, so we can always match the two up at any point in time. The use of that ID also means that switchovers and role changes are much easier because we always know exactly where we are, and therefore the slaves can easily pick up without any interruption from the new master or indeed any other slave. MySQL have started using the global transaction IDs in some of the new releases, and it's starting to show better improvements and flexibility when it comes to switchovers and the management of replication in native MySQL. However, it is still very manual process, prone to issues, and it is still, as I mentioned earlier, it still is in its infancy. Tungsten Replicator is well established and has been used now extensively in production systems for over 9 years. So we're kind of pretty confident that we know what we're doing and we can get that data out and move it around. Now, having the THL available, we can replay transactions if we need to without having to go back to the source. It also means we can regenerate THL if we need to, providing the original binary logs are still available. This process makes it very easy for us to provision additional targets and to recover from errors. I mentioned that we can create complex topologies, and over the next few slides, we're just going to have a quick look at those. Here, this is what we call our simple fan-out process, so one master, multiple targets. Here we've got the source is MySQL, and we then have Hadoop, MySQL, and Kafka as the targets. We just have one installation of the replicator running on that source, and each of the installations of the replicator on the target hook into that extractor process, pull the THL across, and they just apply it. The applier knows what it's applying into, be it Hadoop, MySQL, or Kafka, and will apply appropriate to that target. So this is a great example of how we can have one extraction and feed multiple. These could all be 3 MySQL instances, they could be 3 Oracle instances, they can be any combination of the targets that we support. One step further, we can have multiple sources of different types. So this is fan-in. So here we have 2 MySQL instances and an Oracle instance, and all 3 of those consolidated and fed into a Hadoop target and a Kafka target. I'm sure you can imagine some pretty handy use cases here where you may have 3 different areas of the business using these different sources, but this requirement to consolidate all of that data for reporting and analysis. Having that in one single place will make the process far simpler for your business. One step further, this is a highly complex mix of fan in and fan out, combined with various filtering rules to exclude and include data, both at table here, we've got schema level here, and we also have drop column, so we can exclude even down to the column level. All of these filters available right out of the box, which kind of leads me nicely now to hand over to Matthew, who's going to go into a little bit more detail about the filtering, and it's also going to touch on our clustering products for you. So with that, I'm going to move the slide on more further and hand over to Matthew.
Hey, thanks, Chris. I'm Matthew Lang, and so let's talk about filtering with Tungsten Replicator. We did mention filters briefly on a couple of previous slides, but let's dig a little deeper into what filters can do. And a filter is just an operation that we can perform either on an extraction side or on an applier side, or both. We can use as many filters as we'd like, and we can order the filters as we'd like. So with native, you get basic kind of table filtering, and with Tungsten, you get a whole bunch of different filters and transformations. So, and if you look at the slide now, we kind of have them grouped as to different kinds of filters. So we have auditing filters, right? We can track changes to a table or a system, so you don't really have to roll your own auditing system. We can have content filters, and we actually modify the content or the data in a transaction. So one good use case for this might be if we have an enum field, and we have an integer 1, 2, or 3, and we want to expand those fields to actually have meaningful names. So 1 might mean in process, 2 could be closed, and we can actually expand those on the fly. And so when we write to the target, it actually has the more meaningful name instead of just a number. We have a filter for what we call logging, and all that is when there's an event that we can flag and have it actually write to the Tungsten Replicator log file. So if we want to watch for certain events and just monitor it via the log file, we can do that. We have optimization filters, and these are highly specialized for heterogeneous topologies. So what we might have is an operation that happens in MySQL, and we want to replicate that operation into our target, let's say Vertica. But we know from experience that there's a better way to actually write the transaction into Vertica. And so we can provide some hints to make these transactions more efficient when we apply on the target side. And like I said, these are really used for complex heterogeneous topologies. We have transformation filters. So these are extremely powerful. We can rename schemas and tables. We can merge schemas into a single schema, which is ideal for what we call fan-in replication. So when we have multiple sources of data feeding a single target. So for instance, let's say we have a sales database, an inventory database, and a bill of materials database, and they're all separate installations. We can actually fan in, or what we call replicate, into a single target, and we can prefix, let's say, all the sales tables with sales dash, for instance, so that we know the source from where these tables came from. And we can rename in a whole bunch of complex ways. And then we have some validation filters, and that's just for consistency checking of data. And then a few other filters that really don't fall into any category. We just call miscellaneous. And Tungsten actually includes over 40 filters right out of the box. And there's a mechanism also to write your own filters if you'd like, using JavaScript. You can have a filter that's specific to your business that you can write in JavaScript. You just put your rules into the JavaScript source and include it into the Tungsten configuration. And we have plenty of customers that actually have already done this and these filters are unique to their business. You can also have multiple filters and order them as you see fit. So for instance, it would make sense to have an optimization filter after a content filter. So we would want to maybe modify the contents, modify the transaction, and then at the very last step, apply an optimization filter. We could then use a content filter to prevent certain tables from being replicated to the target, and then use a validate to validate the remaining table data. So let's just look at a few of our popular filters. So the first one, database transform filter. So here we can rename databases and tables, and you can actually search and replace using regular expressions. So it's really powerful when you consider that you can use regular expressions for this. We have an insert only filter. If you just want to replicate inserts and nothing else, if for whatever reason you want to see the original insert and you don't want it to have any destruction of data. Replicate column. So we can actually choose columns to replicate, or we can actually choose columns to ignore during replication. And a good use for that could be if we have a blob field and we're replicating to an analytics system. We don't really need that blob to be replicated into analytics. We really just want data fields, so we might choose to ignore that blob. Our replicate filter, aptly named, it's the most popular one, and really this is used to replicate or ignore certain schemas or tables, and it supports wildcards. So you can choose which schemas you'd like to replicate, which tables you'd like to replicate. You can use wildcards, or you could just say ignore these couple tables. Again, it's used for analytics especially. So for analytics, there's usually a certain set of tables that you want to run your analytics on, and you would use the replicate filter to specify which tables you'd like to be replicated. Skip events by type. We can just skip certain events if we'd like to. We can skip all deletes to schema sales table invoice if we want to. We have a time delay filter too, which is kind of cool. So we basically delay writing events to THL. And if you remember, the THL is our transaction history log. It's our internal format that's generated upon extraction. So with this filter, for instance, you can say have a slave that's 1 hour behind your master, or maybe 12 hours, whatever you want. But it's kind of cool if you just want to see a snapshot, say, of 1 hour before. And then skip rows by data is when we want to actually examine the content of a transaction, the actual data, and then make a decision, do we want to replicate this or not? So there might be a certain field in a row and we decide that, well, for this particular row, we do not want to replicate it for whatever reason. So moving ahead, this is kind of an in-depth view of what we call the pipeline. So the flow of data through the various replicator stages is what we call the pipeline. So here we see the pipeline of a slave replicator, and it has 3 stages. Remote to THL, this is the actual transfer of the THL from the master to the slave. And then the THL is written to disk on the slave. The second stage, THL to queue, another thread in the replicator is reading the THL and puts the transactions into a queue. And then queue to DBMS is the third and final stage, where yet another thread is reading the queue from the previous stage and is writing the transactions to the target. And a master replicator has similar stages, except the first stage is going to be extracting from MySQL, and the last stage is going to be actually sending the THL to slaves. So we can place filters really anywhere in this pipeline, and we can place them either on a master or a slave or a combination. So this flexibility actually allows you to put filters into the stage that is going to handle it the most efficiently. So just an example, let's say we want to replicate a small subset of tables from a master to a slave. We could put the filter on the slave to specify which tables we actually want. And we can put it in the remote to THL stage. So since the remote to THL stage, it happens even before the THL gets written to disk on the slave, the tables that we're not interested will not even be written to the THL on the slave. That would save disk space and reduce I/O. Or if we want to have the full THL that we get from the master and filter it after the THL was written, we could put the filter in the queue to DBMS stage so that we have the full THL with all events and filter just right before we write to the database. So another thing that kind of makes this interesting is that if we look at, if we have a slave and that slave actually may be a master to another slave, because you could daisy chain slaves to one another. And in that case, you want to make a decision. If you're filtering out the THL on an intermediary slave, then that THL is what's going to be sent to the next slave down the line. So do we really want to filter out transactions and not have them in the THL, or do we filter them out right on the apply stage so the THL stays consistent? And it really depends on the topology. And really, there are lots of complex filtering and topologies that you can do by utilizing all these stages in the replicator pipeline. So I'd like to mention our commercial clustering product. And the reason why is because Tungsten Replicator is actually the core of this product. So Tungsten Cluster is a product that provides high availability, disaster recovery, as well as read-write splitting and load balancing to standard off-the-shelf MySQL databases. It sits outside of MySQL, so there's no change at all to your MySQL installation. And its core is the Tungsten Replicator. It also includes a component that we call the connector, which is an intelligent proxy that works with the replicator that provides transparent read-write splitting and load balancing. And as I mentioned, we have automatic failover of nodes in the MySQL cluster. And it comes with a really simple management interface that allows you to control all aspects of the cluster with this one interface. Another thing that I'll briefly go over is what's called a cluster slave. So we can provide a slave to the cluster. We can add nodes to do load balancing for read-write scaling. We can do zero downtime maintenance. We work with all really variations of MySQL, whether it's Percona, MariaDB, the Community Edition for MySQL, or Enterprise Edition. And we have, again, complex topologies. We can do multi-site, multi-master across regions or continents with really high performance. So just to take a look at the architecture. So what we have is a 3-node cluster that we're showing. And at the bottom, we can see our Tungsten Replicator is providing all the replication between these 3 nodes. So the master is the green node in the middle. And then we have the connector on top, which typically gets installed on the application server that provides read-write services. The application connects to the connector, and the connector directs writes to the master and reads optionally to the slaves. And there are a whole bunch of algorithms that we can use for read-write splitting. But one of the key things here is that the connector is aware of the replicator. And what that means is the replicator keeps track of how many transactions behind it is from the master. And it communicates communicates this information with the connector. So then the connector knows, is the slave up to date, yes or no, or how far is it behind? And I'll just cover a couple more slides since we're running a little bit low on time. But if we go to the next slide, we have multi-site, multi-master. And what we've done basically is we've taken 2 Tungsten clusters and joined them with Tungsten Replication in the middle, providing multi-site, multi-master. And what this does is it provides 2 completely loosely coupled clusters, and they can be located across the world on different continents, but replicating to each other, and they both are live and both are taking traffic. And also, by using a Tungsten cluster, I'd just like to talk about a cluster slave real quick. So a Tungsten Replicator can replicate to a target using the cluster as a source instead of a single database node. What this means is that the replicator can connect to any node in the cluster to get its replication data, i.e. THL. If a node were to fail in the cluster, it's removed from the cluster, and the replicator is also aware of this event that just happened. So the replicator will just find another node in the cluster and continue reading from that node. This means your replication stream stays active without any intervention. There's no need to reconfigure. There's nothing to do to bring up replication. It's all handled automatically. So we can have a Hadoop cluster slave reading from a cluster. Anything happens to that cluster, replication stays up because the replicator is aware that we have several nodes in the cluster that we could read from. So we're running out of time. So if you want to know more, have a look at our documentation. Follow us on social media. We have a YouTube channel. Subscribe to it, please. And we have other training sessions as well that you can watch at your leisure. And visit our website to review past sessions and register for future ones. And I would just like to thank everyone again for joining us today, and really hope that you found this useful, and hope to see you on a future session. And we have our contact information there. Feel free to send us an email or visit our website. So thank you.
Well.
Thanks, Chris.
Thank you, everyone. I hope you enjoyed.
Bye.